Question 13. A right-angled triangle is formed by the diameters of three semicircular regions A, B and C, as shown in the diagram. Show that the area of region A is equal to the area of region B plus the area of region C. Well, because of Pythagoras, we know that b squared plus c squared is a squared in this triangle. That's letting A be the hypotenuse here, so the diameter of semicircle A, B for B and C for C. Now, if we are to find the area of a semicircle, that is half the area of a circle. The area of a circle, of course, is pi r squared. And so r for area A is half A, because if A is the diameter, the radius is half of it. And so the area of a circle would be pi half A squared, but we want a semicircle, so it's pi over 2 times half A squared. This is the same for B and for C. We can now write this area of region A, which is pi over 2 times, this will be A squared over 4, is equal to the area of region B, which is pi over 2 times B squared over 4, plus the area C, which is pi over 2 times C squared over 4. But here we have a common factor of pi over 8. Since every term is multiplied by pi by 8, we can divide by pi by 8, and we get back to our Pythagoras, a squared is equal to b squared plus c squared. And so the area of A is equal to the area of B plus C, as we get back to Pythagoras' theorem.